The molecule we're working with here is CH2O. Carbon is the least electronegative atom, therefore it should be placed as the central atom. And I'll connect the hydrogens and the oxygen to that carbon. Alright, for valence electrons, carbon has 4. We have a total of 2 from the hydrogen and 6 from the oxygen. So that gives us 12 valence electrons. I've already used 6 of those electrons. The hydrogens are happy with the 2. They can't handle any more. So I'm going to place the electrons around oxygen to give it an octet. So it already has 2 from the bond. 3, 4, 5, 6, 7, 8. And I have used all of my electrons. 2, 4, 6, 8, 10, 12. However, carbon is still not happy. It only has 6 electrons. Therefore, I'm going to take a lone pair from the oxygen and form a double bond. Now all of the atoms are happy. Carbon has 8, 2, 4, 6, 8, and oxygen has 8, 2, 4, 6, 8, and the hydrogens are happy with the single bonds. Now if I take my central carbon atom, I have 3 groups around that atom. So I have a total of 3 groups, and all 3 of them are bonding and none of them are lone pairs. Therefore, this molecule will take on a trigonal planar type geometry. For the electronic geometry, and because there are no lone pairs, this is also a molecular trigonal planar electronic geometry. Now, is this polar? Well, all the atoms are not the same, even though they are equally distributed. Oxygen is more electronegative, so the dipole would point towards the oxygen. So this is a polar molecule.